Alright, so I've got a list of all of the multiple choice questions that were missed by everyone in CalCAB for our practice test that we did on that Saturday a couple weeks ago. Um, and I picked a couple FRQs that were related to stuff that we hadn't really been targeting in class for the past 2-3 weeks since. So we've done a lot of separable differential equation integration stuff as net change, particle motion. I've talked about area under piecewise functions when we went over the multiple choice and limit definition of an integral, but so we've done kind of all of this stuff in class already. I'm going to focus on these two up here for our FRQs today, and I'll just keep going with more ones that we pull later as we go. Alright, so starting with this one. So there's an amount of water in a storage tank, which is modeled by this continuous function from t equals 0 to 7 hours. In this model, the rate at which water is entering the tank is this function f of t. And the rate at which water leaves the tank is 250 for the first 3 hours and 2,000 for the last 4 hours in gallons per hour. Okay, so here's our two graphs. Which one is f of t and which one is g of t? Just looking at the graph.
Continuous one will be the first one.
First one. I'm not sure what you mean by the first one. So I've got one function that is continuous all the way through and one function that is discontinuous. So
Yes. The continuous one will be the first equation.
Continuous would be the first equation. Okay, cool. So I'm going to color code this really quick. This one is f of t. And then here in green is g of t. Okay. So our graphs of f and g intersect at this t values that they were given here. At t equals 0, the amount of water in the tank is already 5,000 gallons. I want to know how many gallons of water entered the tank during our interval from 0 to 7, and then to round our answer to the nearest gallon. So what do I have to do first?
Just integral the first equation.
Okay, we're going to integrate just the first equation. From what to what?
0 to t, 0 to 7.
Okay, from 0 to 7. Looks good. I'll go ahead and throw this in a calculator and we'll do that together. Okay. So I've got 100. Actually, let me throw this in as a variable. That way we can use it later if we need to. 100 x squared times the sine of the square root of x. And make sure I'm in radians. We are. Okay, and we're going to integrate that. So math 9. Our function, variables, y variables, function y1 in terms of x. From x equals 0 to x equals 7. Oh. I missed a comma. There we go. Okay, so this is 8,264 gallons since they asked us to round to the nearest gallon. Do I need to add my starting amount or not for this question?
No.
Okay, we don't need to add the starting amount, you're right, because we're only looking at how many gallons actually entered the tank. And if we're only looking at the amount of gallons that are entering the tank, we don't need to know how many gallons were already there. 8,264. Okay, we integrated a rate in gallons per hour in terms of time, and we ended up with gallons. For part B, I want to find the time intervals during which the amount of water in the tank is decreasing, and then give a reason for our answer. What do I have to do? Can you give me a formula that would give me the change in the amount of water in the tank? So,
Change
not just entering or leaving, but total change.
ft minus gt.
Okay. So our rate at which the water is changing, which I'm going to call a prime t, so the change in the amount of water at any time, would be equal to our rate at which water enters minus our rate at which water leaves the tank.
To add 5,000.
In this case, no. If I'm looking for the actual amount of water in the tank, then I would add the 5,000. So instead of a prime, if I was looking for the amount of water in the tank, then that would be the integral of ft minus gt dt. So the total amount that came in minus the total amount that left. And then I would add 5,000, our starting amount. But if I'm just looking for how fast is the water changing in the tank, this would be how fast the water comes in minus how fast the water goes out. Okay. I'm going to erase this, we'll probably come back to that, but for this question, I want to know when the amount of water in the tank is decreasing. I've already got a slope of the amount, would be my rate of change in the water, right? So what has to be true when the amount of water total is decreasing?
In a prime t should be negative.
A prime t should be negative. Okay, so that means the rate at which water is leaving should be larger than the rate at which water is entering the tank, right? A prime t is negative if f of t is less than g of t. Okay, so now I'm going to go back to our graph. We're looking for all of the points when f of t is less than g of t. I'm also going to mark my intersects here, since they gave those to us in the question. T equals 1.617 is our first intersect. And our second intersect is at 5.076. Okay, so looking at this graph, when is f of t less than g of t?
1.617
Looking for a range, so from what number to what number? From what time to what time?
should be 0 to 1.6.
Okay, from 0 to 1.67. Okay, and I'm including 0 there because 0 is included for f and for g. But not including 1.617 because they're equal at that point. And then is there any other times?
3 to 5.0.
Okay, and when 3 is less than or equal to t is less than 5.076. Okay. The amount of water is decreasing. Any questions on what we did for B? Okay. Check, see if it's just us. So participants. Okay, just us still. So for part C, I want to know at what time is the amount of water in the tank the greatest, and then calculate the amount of water at that time to the nearest gallon. So I'm going to do this in another color over on the right, maybe. So if I want to maximize the amount of water, what would I need to do?
Integral the first one. The
Okay, so if I integrate this equation that we just had, I will get the amount of water at any time is equal to what?
integral FT.
Integral of ft minus
dt.
gt dt. From what time to what time? What time do we start? Jen, you there?
Yes, I'm here.
Yes,
Can you
okay, sorry. So we're integrating from what time to what time? What are our bounds?
from 0 to 7?
Okay, so from 0 until whatever time we want. I could plug in 7, that would give us the amount at 7. We can make this any t we want. And when I integrate, I'm also going to get a plus c, right? That c is going to be our constant that we had when the amount was 0. How much did we start with?
5,000?
5,000. Okay, I'm going to erase this and give us a little bit more space, but this will be 5,000 plus the integral of our rate should equal our amount of water we have at any time. Okay. So I could use this with a candidates test maybe, because in order to have our maximum amount of water, I'll either have to have a relative maximum, or I'll have to be at a start point or an end point. So we can test all of our critical points, points where our slope of this equation, or a prime t, this one, is equal to 0. Solve for t, and then test those points and our start point and end point to see when our amount of water was the largest, using this equation we've just created. Okay, so let's set that up. when would ft minus gt be 0?
Should be intersect.
Okay, the intersection points. ft minus gt will be 0. I also have, for our piecewise function, we jump at 3. So I've got intersection points and 3. So I'm going to make a table really quick. T and a at t. At start point 0 intersects t1, t2, and our end point at 7. But I also have one more point. What's the point where we jump?
Five.
Not 5, no. We do have an intersect at 5.076. But there's a point where our piecewise function changes.
T3.
3. Okay. So now I need to figure out when this changes from positive to negative or negative to positive, so we can see whether any of these could be the maximum or not. So ft minus gt, will that be positive or negative before t1? Okay, here's our graph again. Before t1, so before this point, is ft minus gt positive or negative?
TQ.
Sorry, your microphone broke up a little bit. Can you say that one more time?
Negative.
Okay, it will be negative. So I'm changing from negative to positive at t1. So t1 is a relative minimum, which means it cannot be the maximum. Okay, what about t2? Is t2 a relative minimum or maximum?
E maximum.
Is ft minus gt positive or negative before t2?
Oh, it will be.
Okay, negative, and then it changes to positives. This is another relative minimum, actually. Okay, then before I hit t equals 3, is ft minus gt positive or negative?
Positive.
Positive. After t equals 3, is it positive or negative?
Also positive.
After t equals 3?
Third. Equal. Oh, it's negative.
Alright, so we changed from positives to negative at t equals 3. So this is a relative maximum, which means it's possible for the candidates test. So I really only have 3 points that I need to test. I need to test t equals 0, which we already know there was 5,000 gallons because that was given. I need to test t equals 7, which we'll have to actually plug into a calculator to figure out the amount. And I need to test t equals 3 to figure out if we had the most amount of gallons at those points. I'm going to write these in red, I think. $5,000 gallons. Okay, so to test these, at t equals 3, this is going to be the integral from 0 to t of ft minus gt. But gt, when t is 3, is going to use our top part of our integral. So this will be 250 times t will give us our gallons per hour of gt. So really, our amount at any time is going to be different whether I am before 3 or after 3. I'm going to write our amount as a piecewise function, so I'm going to rewrite this really quick. So you can see what's happening maybe. Okay, so when t is less than or equal to 3, our amount would be our starting amount, or 5,000, plus the integral from 0 to t of f of t, minus g of t, which is 250. In terms of time. After t equals 3, what should my new equation be, though? Okay, so this is going to become, instead of my amount at 0, my start point will become 3 for my integral, which means this one should be our amount at 3, which we'll get in a second. But I'm going to have my amount at 3 plus 3 to any time of what?
Minus 1,000.
Minus 2,000. Okay. And that's when t is greater than 3. Right, this way. T is greater than 3 but less than 7. Or equal to 7. Okay. So in the calculator, I'm going to type in this first part here. We'll solve for the amount at 3. And then we'll go down to the second line. And once we know the amount at 3, we'll add another integral from 3 to 7 of ft minus 2000 dt. Write that dt for everybody reading afterwards. To see how much amount of gallons we had at 7. Okay, so this looks something like this. I've got f of t in the calculator already, so what I'm going to do is I'm going to add 5,000 plus our integral, math 9, of variables, y variables function y1, so that's f, minus 250, in terms of x from 0 to 3. Okay, so I've got 5,126.591. And that's also my amount at 3 that I'll need for the next equation. So I'm going to take that answer, and I'm going to add the integral of our variables, y variables function y1, which is our f again, minus 2000. In terms of x, from x is 3 to x is 7. Okay, and our amount at time 7 is 4,513.807 gallons. Okay, based on our candidates test, when is the amount of water the greatest? Okay, at t equals 3. Write something like the amount of water is greatest